Howdy. I wanted to recap what we talked about in class today and show an example of vector addition, subtraction, and scalar multiplication. As we talked about in class, when we add vectors a plus b, then we're going to take those vectors and we're going to place them head to tail and connect. Algebraically, when we add them, we add components. So here I have a vector a, which is 3, 2. That is, it is 3 over and 2 up. And here I have a vector b, that is 2, negative 4. That is, it is 2 over and 4 down. Notice that in both cases, we count the vector starting at its tail. So if I wish to add b's, a plus b, I'm going to grab b and place its tail on head a, like so. And I'm going to connect like this to get a plus b. Geometrically, it appears that a plus b is 5 over and 2 down. So we would say that a plus b is 5, negative 2. But if we add them algebraically, we get the exact same result, which is really nice. A plus b should be the sum of the components. So we get 3 plus 2 is 5, and we get 2 plus negative 4 is negative 2. So whether we do it geometrically or algebraically, a plus b comes out to 5 plus negative 2. If we wish to subtract, then a minus b is going to be found by placing the vectors tail to tail and connect to the positive. And by the positive, I mean this vector right here. So if we think of this as a plus negative b, then we're thinking of a in its positive sense, or just as it is, negative b would be the opposite of b. We're going to connect towards a. So to subtract a and b, okay. Let's grab, having trouble. Okay. Make sure that we're doing the right things. Grab a plus b to get it out of there. And what we'd like to do now is a minus b. So we're going to grab b. We're going to place it now tail to tail with a. And we're going to connect from b to a. And the reason that we're going from b to a is that we are looking for the difference a minus b like this. And looking at that difference appears to be, should be a little better if I cut the here. If we look at that difference appears to be 1 over and 1, 2, 3, 4, 5, 6 up. So it appears from the graph that the vector a minus b is 1, 6. If we subtract algebraically, we get the same result. A is 3, 2. B is 2, negative 4. And if we subtract a minus b, we're going to have 3 minus 2 is 1. And 4 minus negative 2 is 6, giving me 1, 6 for the difference a minus b. And finally, for scalar multiplication. A scalar multiplication reflects a stretching of the vector. So if we multiply a times 2, we keep the same direction, but our magnitude is doubled. In other words, our vector stretches in length. And so, for example, if I wanted 2a, then the vector 2a would be found by taking a and doubling each of its components. So instead of 3 comma 2, I would have 6 comma 4. In other words, I'm going to go 6 over and 4 up right here. And you can see that 2a has the same direction as a does, but it is twice as long. We write that algebraically as 2 times the vector 3 comma 2, which is 6 comma 4. Notice that if you multiply by a negative, then you are going to reverse the direction. So negative 2a would be negative 6 comma negative 4. And that would be back 6 and down 4. And algebraically, we would write that as negative 2 times negative 3 times 3 comma 2. And that gives me negative 6 comma negative 4. So the scalar multiplication algebraically is simply a matter of multiplying components. I hope this example is helpful to you.